Hello students, Rajiv from myetutors. In today's episode, let's discuss vapor pressure and Raoult's law. So let's dive into details to understand vapor pressure and Raoult's law. The very first visual image that comes to your mind when I ask you what is boiling point. I have seen majority of students reply it is the temperature at which liquid boils, but this is not the exact definition of boiling point. It is a temperature at which vapor pressure of liquid is equal to atmospheric or external pressure. Say I am boiling a liquid and it is kept on a tripod stand. This is a Bunsen burner and I am boiling it. So this liquid, when the vapors that are evolving from this liquid, is equal to the external pressure that is applicable over this liquid, would give its boiling point. That's the reason boiling point is always expressed at a peculiar pressure. Now, the boiling point of water is 100 degrees centigrade at 1 atmospheric pressure. Because when it is 1 atmospheric pressure, then only it will boil at 100 degrees centigrade. But if pressure decreases, suppose 1 atmospheric pressure would be at sea level, so that would have 100 degrees centigrade temperature, that is the boiling point of water. But suppose if the same quantity of water is boiled at an altitude of say 3000 meters or 4000 meters above sea level, then this boiling point can change and it would not be exactly 100 degrees centigrade because the corresponding atmospheric pressure has changed. You have studied that cooking is prolonged when it is cooked in open vessel in a hill station. The reason is because boiling point of water changes, it is slightly lowered down from 100 degrees centigrade, and so more amount of heat is required. Now, while explaining boiling point, I have mentioned vapor pressure many times. So, the next thing would be, what is vapor pressure? So, let's try to understand vapor pressure. So, the vapor pressure is the vapors that are evolved from the solution. So, the vapors that are evolved from the solution creates vapor pressure. So the definition of vapor pressure would be, it is the pressure exerted by the vapors in equilibrium with the solution at a given temperature. So to understand vapor pressure, let's consider a beaker in which water is placed. Say 200 ml of water is placed in this beaker, and another beaker is kept upside down. Now, due to evaporation, some vapors will evolve from the surface of the liquid, say surface of water, and after a lapse of time, they will be in equilibrium. That is, the rate of evaporation and rate of condensation would be same. So that state is known as equilibrium, and in that state, the pressure that is exerted over this surface would be termed as vapor pressure. So, in vapor pressure, the vapors should be in equilibrium with the solution, and the pressure cooker works only on this principle. In pressure cooker, vapor pressure is created, which results in faster cooking, because with increase in vapor pressure, the boiling point of solution would also increase, and as boiling point increases, more amount of heat would be absorbed by the solution, and so cooking becomes faster. So this principle works in the pressure cooker. So now let's see what's Raoult's law. So according to this law, the vapor pressure of a solution, and I am considering a binary solution, which is formed by mixing of two substances. Here I am considering miscible liquids, that is a homogeneous solution is formed when two liquids A and B are mixed. So for miscible solutions, Raoult's law is that the total pressure of the solution is simple algebraic sum of partial pressure created due to liquid A and liquid B. So it is simple algebraic sum of partial pressures of two liquids, or if it is a trinary solution, then it would be for three liquids. Now partial pressure would be part of the total pressure created by a component in the mixture, and it is total pressure into mole fraction, and this is according to Dalton's law of partial pressure. But in case of this Raoult's law, we will use this relationship, that partial pressure would be equal to vapor pressure of pure liquid A into its mole fraction, and this vapor pressure of pure liquid A is same pressure when pure liquid A is present at the temperature of solution. Similarly, partial pressure of B would be equal to vapor pressure of pure liquid B at the temperature of solution into mole fraction of B. So we can write the equation like this, that partial pressure of solution would be equal to P naught A XA plus P naught B XB, and this is Raoult's law for binary solutions. Now let's try to understand Raoult's law using graphical method. So say this is say vapor pressure of liquid A, and at this position I am considering mole fraction of A to be equal to 1. So mole fraction of B would be equal to 0. Similarly, say at this point mole fraction of A becomes 0 and mole fraction of B is equal to 1. So this would be vapor pressure of pure liquid B, because at this position 100% liquid B is present, and at this position 100% liquid A is present. Now say this is the vapor pressure of this liquid A at a given temperature, and because mole fraction of A is 0, so vapor pressure would be 0. So if I connect these 2 points, this is how vapor pressure of A should decrease when mole fraction of A decreases in the solution. Say at this point it is 0.9 mole fraction of A, this is 0.8. So as we are decreasing mole fraction of A, the corresponding vapor pressure of A should also decrease. Now say this is the maximum vapor pressure of B when it is 100%, because vapor pressure is dependent on boiling point. So boiling point of two liquids are different, so they will have different vapor pressures at same temperature, and I am not considering at their boiling point, because if I consider it at a boiling point, then both will have same vapor pressure. Now at this point it would be 0, so connecting these 2 points would show decrease in vapor pressure of B as mole fraction of B decreases, and as mole fraction becomes 0, the vapor pressure of that liquid B should be 0. Now connecting these 2 points would give me vapor pressure of solution. So this is vapor pressure of solution, So I can write it that this line would represent P naught A XA plus P naught B XB. This is P naught A XA and this is P naught B XB. So this is about graphical representation of Raoult's law. Now suppose I have to calculate vapor pressure of a solution at a given mole fraction. Say at this point mole fraction of A is 0.55 and mole fraction of B would be 0.45. So if I extrapolate this point, so the intercept with the lines would give the corresponding vapor pressure contributed by liquid B, liquid A and the effective vapor pressure of the solution. So this would be the contribution of vapor pressure of liquid B in the total vapor pressure of solution, and this would be the contribution of liquid A, and this is the vapor pressure of solution. Now let us consider one or two examples for Raoult's law. Say we have a solution with equal weights of benzene and toluene, and we have to calculate vapor pressure of solution. If vapor pressure of pure benzene is say 300 millimeters of mercury column at a given temperature, and at that same temperature vapor pressure of toluene is say 190 millimeters of mercury column. So we can calculate the vapor pressure. So first would be mole fraction. So mole fraction of benzene can be calculated because equal weights are given. So it is x by 78 over x by 78 x by 92, which comes out to be 92 over 92 plus 78. So this comes out to be 92 over 170, and solving this it comes to 0.541. So mole fraction of benzene is 0.541. Therefore mole fraction of toluene would be 1 minus 0.541, which is 954. So 0.459 is mole fraction of toluene. So now we can calculate the vapor pressure of solution. So it would be, vapor pressure of solution would be 300 into 0.541 plus 190 into 0.459. So calculating it comes out to be 162.3 plus 87.2, which is 249.5 millimeters of mercury column. So this is how a simple calculation for Raoult's law can be carried out.